everyone, I'm Sania Dona Shaji, a student of Plus One. I would like to discuss with you the topic of Lewis structures. Lewis structures. A Lewis structure is a pictorial representation of covalent bonding between the combining atoms. It can otherwise be defined as the two-dimensional model that represents covalent bonds as straight lines and unbonded valence electrons that are in the outermost energy levels of an atom as dots. Lewis structure can be easily drawn by following a very few simple steps. Step number 1. Represent all the atoms by their chemical symbol. Step 2. Draw the skeletal structure of the molecule. Step 3. Calculate the total number of valence electrons. Step number 4. Draw single bonds to the central atom. Step 5. Arrange the remaining valence electrons as lone pairs. Step 6. Turn all the lone pairs into single or double bonds to satisfy the octet rule. Let us draw the Lewis structure for water. Following step 1, representing all the elements by their chemical symbol. Here H2O is the chemical symbol of water. Step 2. Draw skeletal structure of the molecule. While drawing the skeletal structure, always remember to place the less electronegative atom at the center. It is usually the element there is only one of. Here we have one oxygen atom and two hydrogens. Hence, let us place the oxygen at the center. Step 3. Calculate the total number of valence electrons. Always remember that within any given column, all the elements have the same number of valence electrons. For that, let us now take a look at the periodic table. To find the valence number of electrons, we have to count the number of columns starting from the left, skipping the transition metals. And also note that helium has an exception. It doesn't have 8 valence electrons but only 2. Here we have to find the valence number of electrons for hydrogen and oxygen. The valence number of electrons for hydrogen is 1. And the valence electron of oxygen, as you can see, is 6. Calculating the total valence electrons of water. Valence electrons of hydrogen, 2 times 1 equals 2. Valence electrons of oxygen, 1 times 6 equals 6. Total valence electrons, 2 plus 6 equals 8. Step 4. Draw single bonds to the central atom. Now let us draw single bonds to our central atom, which is oxygen. Always keep in mind that a single bond represents 2 electrons, a double bond represents 4 electrons, a triple bond represents 6 electrons, and 2 dots represent lone pair electrons. Step 5. Arrange the remaining valence electrons as lone pairs. We have already drawn 2 single bonds, that is 4 electrons. Now, let us reduce it from the total valence electron, hence we get 8 minus 4, which gives us 4. Let us represent these 4 electrons which are remaining as lone pairs around the oxygen atom. Here you can see that all the oxygen Step 5. Arrange the remaining valence electrons as lone pairs. We have already drawn 2 single bonds, that is 4 electrons. Now, when we reduce these 8 minus 4, which gives us 4. We can represent these 4 electrons as lone pair along the oxygen atom. We can see that oxygen has 8 electrons and thus satisfy the octet rule. Hydrogen only needs 2 electrons. Hence, this is the Lewis dot structure for water. Let us take a look at another example. Sulphur trioxide. When we represent it by its chemical symbol, we get SO3. Now, let us draw the skeletal structure as well as the single bonds. Calculating the total valence electrons of sulphur trioxide. Valence electrons of sulphur, 6 times 1 equals 6. Valence electrons of oxygen, 6 times 3 equals 18. Total valence electrons, 6 plus 18 equals 24. We have already drawn 3 single bonds, that is 6 electrons. Let us reduce it from the total number of valence electrons, that is 24. So, 24 minus 6 gives us 18. Let us represent these 18 electrons as lone pairs around the oxygen atoms. Here, as you can see, all the oxygen atoms satisfy the octet rule, but the sulphur does not. It doesn't have 8 valence electrons and has only 6. So, we need 2 more electrons. For this, let us turn one of the lone pairs of the oxygen atom into a double bond. Now you can see that all the elements satisfy the octet rule. This is the Lewis dot structure for sulphur trioxide. Thank you for watching my video. Please express your opinions in the comment box below. And don't forget to share, like and subscribe.